All right, so I'm going to talk about the three kind of cloud computing like consumption models, really deployment models, consumption models. It's not going to be any real surprises there. And then I'm going to talk about from AWS's perspective what the 6 benefits of cloud computing are. This is actually fairly important, just because this will actually show up on the exam. They are going to ask you questions about this. Now, we are going to use this model where we talk about coffee shops a lot. So, for example, we go to a coffee shop, we usually say, hey, I'd like a double decaffeinated half calf green tea matcha latte with, whatever, lavender, whatever we're putting in them now. And so you're like, Michael, that was really specific. So we go in and we talk to mainly the cashier, and then we say, hey, I'd love to get this coffee. And then they say, well, this costs you $5. You pay for it, and you get a response. And so there's this back and forth that happens. They say, what would you like? You respond. And so there's this whole exchange that happens. When we make a request and a response, that kind of exchange is very much like the standard kind of like client server computing model now, where we're actually talking to a system, whether it be a person or a set of APIs, like a server just sitting there listening for us to talk to it. And what happens is we say, hey, I'd like a virtual machine of this size with these parameters launched in this location. The server says, hey, I got your request, I'm executing it. That's it. It's like we ordered a cup of coffee and they gave it to us. So that's us making a request, and then they respond to the request. So the server evaluates the request in this particular case, a virtual machine, and then it returns the information back to the client. Now, whether that's a long period of time or short period of time, obviously that depends on what you're asking for. But typically in computing, it's quick request responses, like usually not more than a second, although they can go up to minutes of, until a response, but those are longer term, like more persistent connections. Now, why is cloud computing so hot? Like Michael, you were just like, yeah, it's not kind of an afterthought now. When did it become the main thought? Well, does anyone know exactly when AWS released their first service? Like AWS, not Amazon, but AWS. Does anyone know when they released their first service? And has a bonus what that was? No? So the first service was actually released in 2006. And the first service was actually called SQS, which is the simple queuing service. And then there was S3 and then EC2. So oddly enough, they had queuing, storage, and virtual machines as the first services, right? So 2006 is when it first came out. And it actually came out to a lot of fanfare where people were like, what? This is interesting. Now, somewhere like, who cares? I mean, we had Heroku back in 2005. I mean, we had like Linode and DigitalOcean and other companies. I don't know if DigitalOcean was there, but Linode was definitely there. And we had other VPS providers. Like, what was the big deal? What's the difference? Like, who cares that AWS came out with this? Here's what changed when AWS came out. First, they were the first ones to offer enterprise class services where with a credit card, you could pretty much provision it in 15 minutes or less, and you could get those services globally. And, at the time they only had a few data centers, but they were ready to go out of the gate. And so you could literally get, a couple hundred servers within like an hour, which at the time was unheard of. So if you needed to run a proof of concept or some other variant, it could easily be done. And I got to tell you, what was funny about this is that I remember standing in front of the CTO of Southern Company, which is the power company down here in the Southeast. And he said, we're not using cloud at all. And I could see out of the corner of my eye, the head of engineering kind of like duck his head a little bit. And I was like, well, I'm sure that some of you are using AWS. This is 2010, by the way. So literally 4 years later. And he goes, why would we use AWS? I mean, we have a perfectly healthy IT team internally. And I said, well, it's probably because it takes you, 6 weeks to 8 weeks to get a server. if you want to run a proof of concept, as long as you don't violate any company security constraints, you could probably run a proof of concept in like a couple days, you know? And I remember that at that point in time, the guy who I saw kind of hunkering down actually like spoke up and was like, yeah, we usually bill it on our credit cards because we don't have a relationship with AWS, right? And the reason is that this allowed you to access service on demands. You didn't have to buy a large amount of hardware, and you could just provision what you needed and then just give it back when you were done. That was unique at the time. No one was allowing you to just cut bait and run if you ran something for an hour and then pulled it out. Because at the time, AWS was doing per hour billing. They weren't doing per second billing like they're doing now. So imagine like you could, you could spin up some servers for 6 hours and then delete them, and then you stop paying for them. That was unheard of at the time. If you went to your internal IT team, you had to go like provision hardware. Do we have hardware capacity? What's the approval? What security zone does it need to be in? Blah, blah, blah. All of which are actually still legitimately valid questions to ask for a production AWS deployment. But if you're doing a proof of concept, it just was so much easier for people to innovate. And so largely what you found is that engineering teams, like software engineering teams, were driving the push for that because they needed to experiment. And unfortunately at the time, DevOps was not a thing, and IT teams were just kind of getting in the way of they were compliant, they were supporting the business, they were protecting the business, but sometimes at the expense of innovation, which is what most companies needed at the time. So you have to find that healthy balance, right? But this is what made AWS differently, is that accessing services on demand, avoiding investment in hardware, and provisioning compute as needed, and you only paid for what you need. This was utility computing at its finest, right? Now, there are generally considered 3 consumption models for AWS, well, for cloud in general, right? Any of the cloud providers. One, you're either all into cloud, or you're all into your data center, so you don't have any cloud presence, or you're hybridized. Now, in 2010, Gartner, the remarkably unbiased purveyor of the future, which that was sarcasm in case you didn't know. They are somewhat biased, but for the most part, their predictions are pretty accurate. They said in 2010 that the #1 barrier to adoption for AWS would be security. And guess what? That turned out to be true. Until AWS reached a certain level of security certification and competency, until we had walked through a few audits with AWS, or at least heard our friends walk through a few audits, we weren't going to trust somebody else with our data. Turns out, by the way, that for most of us, they're way better at security than we are. And other cloud providers have struggled with that, right? Google not so much. Azure has struggled with it greatly. But also, there are pros and cons for every provider, right? The reason I mention that is that one of the big reasons to not come out of your own premise was control and security. Now, control is still a valid reason to stay in on-premise, but security is just slightly less of a reason, unless you have stringent security requirements, which honestly, when you work for the government, you have stringent security requirements. So in the public sector, in the private sector, so public infrastructure, right? So general corporations like Google, Cloud Native, that kind of thing, those kinds of companies wanting to consume public cloud, totally works for them. But for other companies that are associated with the DoD or other government level entities, coming out of on-premise and moving into cloud required them to create things like GovCloud or other special kind of infrastructures that can cater to those use cases. But these were the general models: is you were either all in the cloud, you were either all in your data center, or you used a mix of both. Now, every startup since 2012 that I've met, unless they're specialized in some kind of like government relationship, they're all in the cloud. Nobody's running their own servers anymore. It's no longer cool. And the reason is that businesses don't care. They don't want you to become good at running servers unless you're either a consulting company or you yourself are a cloud provider. It's not, there's no business benefit, right? Now, I say no business benefit, obviously. If you are managing servers, you want to be good at that for an insurance company or for somebody else. But do we really need to be good at running cables underneath the floor in order to rack up our systems? Not necessarily. We can pay somebody else to do that. So this is where these models come in. It's where, all the companies I know from 2012 forward are pretty much all in the cloud with notable exceptions. And I don't know of a single company right now that is running exclusively in their own data center who is not either related to the government or some kind of cloud provider. And even those guys, for the most part, are also hybridized, meaning they're running something in the cloud somewhere. One other thing I want to dispel is that some people will talk about vendor lock-in and kind of running multi-cloud. Multi-cloud just means the ability to run a single workload in multiple cloud providers, not run one workload across 2 or more cloud providers. Unfortunately, with the way networking and latency work now, running across multiple cloud providers can be done, but becomes with a tremendous amount of headaches. So when people say multi-cloud, they're really just talking about how corporations can actually use multiple cloud providers depending on the needs of the particular project or workload, which honestly is super important. So tools like Terraform, Packer, Pulumi, things that are cross-platform kind of enable that kind of run. So I think there is another consumption model, which is called multi-cloud nowadays. And just to kind of reaffirm this, obviously cloud-based means you're running everything in the cloud. On-premise means you're running everything inside of your own resources. And this is where like VMware and Hyper-V and Zen and Heat, kind of live. And of course, that hybridized mixed mode. And Gartner in 2010 said that in 2020, this is where 90% of companies would be. It's actually far more than that. Most of us are in a hybridized space now. Now, one thing that's probably worth showing is that AWS has a ridiculous console. When I say ridiculous, there are so many services in the AWS console, also known as the management console. And you're going to see like logins and 2-factor and stuff like that happen. I was joking recently because LastPass showed up as having an issue with like master passwords and security breaches and all this other stuff. And I was like, are those people not using like multi-factor authentication? Because how do you even get logged into somebody's account if you can't actually see the MFA code? Anyway, so people are like, well, not, someone stole like reusable passwords and whatnot from LastPass, but I gotta tell you, with multi-factor MFA, including time-based passwords, it'd be really hard to crack somebody's account. But that's just me. Let's see. So here I am logging in. Oh, that's right. They just launched a new console. You know what? Let's keep the existing console. I remember yesterday they just announced that they have a new console. So here's what you should know. I just logged into the management console. This is one of the 3 ways, by the way, you can access AWS. Note that there are a ridiculous number of services here. You do not need to know even a majority of these services. All you need to know is the services that are relevant for what you do, either, analytics, application hosting, application development, application design, right? Application security, right? Business analysis, like just knowing in general, like costing, what services fit that. So just know that there's a lot of opportunity to learn, like get completely overwhelmed here. Don't get overwhelmed. We're really only going to focus on about 20 to 30 services today. And it's still going to feel like a lot, but notice that there's like 300 here. So don't worry about it, right? Just in general, walk away with a high level knowledge of what the service does based on what I share with you. That's all you need to know. I'm going to at some point be like, oh, what's the new console? What is that all about? They're like, hey, we want you to switch now. Hey, let's take a quick look so you guys can see the new console. Oh, recently visited. Oh, like here's some interesting. We've added widgets to the whole thing. Here's some health. Welcome to AWS. Oh, billings right off the bat. Trusted advisor, explore. Well, that's funny. Okay. Here's my question for you. How would I add another service? Well, I go to the top and just search for like EC2. And I bet if I did that and I visited EC2 and then I went back to console home, I bet you EC2 would now show up down here. Yep, there it is. So just know that they released a new console. Okay, so don't get overwhelmed. You only need to focus on what's important for you. Any questions about the 3 deployment models or the kind of general definition of cloud computing as basically self-provisioned software-defined infrastructure? Okay. Let's talk about the benefits then. It would really behoove you to write these down because these do show up on the certification if you decide to take it. 1, Amazon wants you to trade what they call capital expenditure for variable expense. They used to say, by the way, operational expenditure. So they want you to trade capital expenditure for operational expenditure. And what they're doing now is they're saying, no, we want you to trade CapEx, so capital expenditure, so investment in hardware, data center modules, power modules, cooling modules, all of that. We want you to trade that for a variable operational expense, but variable expense is how they usually talk about it. So the idea here is that how do we get to pure utility computing? Well, where you're only paying for what you actually need and or use. So that's the change here. So that's the first benefit. The second benefit is that now we can optimize spend because you no longer need to spend money on running and maintaining data centers, at least not at the same level. Even if you're hybridized, you're running a much smaller data center footprint. And so you don't no longer have to get like really good at running, hyperscale data centers across the entire world, because you can run maybe like 3 or 4 data centers, keep those spread out. And now you can focus the rest of your resources on just doing what's core to your business. So your investments focus shifts, and so there's more cost optimization there. That's the second benefit, according to AWS. The third is capacity. And what this means is that you can now only consume the capacity you need based on demand. So people say like you can stop guessing capacity. That's not right. What this means is that you can now fix your guesses. I'm sure none of you have been on a project where someone has said, we have to have 50 servers because we're going to have 40,000 connections per second on day 1. And you go to launch and you launch those 50 boxes, you've ordered the hardware, you've done all this stuff, and you needed 10 servers. Or worse, they said you needed 50 and what you actually needed was 200. And now the users can't use your site because you can't scale because you don't have enough hardware capacity. So this really fixes the capacity problem because you can stop guessing capacity or you can fix your bad guesses. Because if you need to add, 4,000 servers, you can do that. Out of the gate in a single location with no change in account limits or no discussion with AWS, you can run 1,900 servers, standard boxes. So if you want to spin up 1,900 boxes on day 1 of your account, you don't even have to talk to anybody. Now, if you want to spin up more than that, you might need to go to another location to do that. Or you can just open a quick ticket with Amazon and say, hey, I need 10,000 boxes. They're going to ask you why. You give them a quick justification. They're not even going to examine that really closely. And then they'll give you access to it. Okay. So if the first is trading CapEx for variable expense, the second is optimizing costs, as you can just focus on what's core for your business and no longer run data centers. The third is capacity, meaning you can just stop guessing at capacity and you can fix your bad guesses at capacity and really just keep capacity slightly ahead of demand as demand changes. Fourth is that the funny thing is that the more you use of AWS, the more, like, the cheaper it gets per unit, like per gigabyte as an example. Also, as they grow in size, they tend to pass their efficiency savings and cost savings back to the customer. I don't even know how many times they've lowered costs, for example, on S3 or come out with a better, virtual machine. So these economies of scale translate into like lower pay-as-you-go prices. So that's the fourth benefit. The fifth is that proof of concept idea that I was touting before. Now you can just go test your ideas. Go spin up 15 boxes, launch an Elasticsearch cluster, spin up Kafka, get your new security tool up and running and have it do penetration testing. It's like that. You're no longer constrained about hardware ordering capacity. Do we have the skills? Do we even know how to run Elasticsearch? AWS can handle that for you. So your innovation, your speed and agility around innovation just goes through the roof. And last but not least is that you can go global in minutes. You want to launch a web server in Virginia, but then all of a sudden you find out that in Europe you're like super popular and your website's predominantly static. Guess what? You can throw CloudFront in front of that, and that service can be global really fast, really quickly. You need to replicate that to a data center in Europe, you could do that as well. So we're going to explore AWS's global infrastructure in greater detail later, but just know that it's real easy for you to serve customers globally with AWS with just a few clicks. Now, in general, AWS likes to group things into compute, networking, storage, databases, security, and then you see management and governance. That's pretty standard. There obviously, as you saw before when we were on the console, there are other services. So they no longer offer a full service list like they did before. Realize I'm going to have to shift my tooling on that. But like, for example, if you're looking for Kafka, they've got managed Kafka. They also have their own private one, Kinesis. So if you're looking for analytics, you can get access to all of the analytics tools, the listings of them right there. So there's other categories than just these 6, but these are the primary ones we're going to focus on. All right. Quick knowledge check. By our definition, what is cloud computing? Like, what's a good fix for cloud computing? A good definition. Good. I see that someone put C, right? Which is a bunch of actually put C. Using on-demand delivery of IT resources and applications through the internet. That's pretty accurate, actually, right? You know, one thing about the cloud providers is they're all available on the internet. It is on demand, and it is the delivery predominantly of IT resources and services. So C is accurate. Excellent. Good. Other question. What's another name for an on-premise deployment? So I'll give you a hint. If AWS is a public cloud and that's a in cloud space, what's an analog for on-premise in terms of, like, what's the opposite of public cloud? Good. Yeah, C. I kind of take offense to that word because while I love VMware and was at one time a VMware administrator or Hyper-V or whatever, those services do not have the capabilities of a cloud provider, even at a basic level. Now, don't get me wrong, when it comes to running virtual machines and containers and other pieces like that, remarkably good products, solid, but they don't even have the same API driven infrastructure. So I wouldn't compare a private cloud provider to a public cloud provider by any means. Okay, out of the 6 benefits that we talked about, right? So like, you know, variable cost, the capacity, cost optimizations, that kind of thing. How does the scale of cloud computing help you save costs? Like, what is it that over time makes AWS cheaper for you? Good. I see a bunch of you filled in B, right? Aggregated cloud usage from a large number of customers results in lower pay-as-you-go prices. That's accurate. Yeah, that's the economies of scale piece, right? Now, just to say this, you don't have to invest in technology resources before using them. This basically means you don't have to buy hardware before you buy like software. That's A, right? So A is not right because that relates to trade upfront expense for variable expense. Accessing services on demand helps prevent access to limited capacity. That's related to capacity. So stop guessing capacity. And then quickly deploy applications to customers is related to going global, right? So it really is B, right? B is about, that's how you save costs, is that they pass cost savings on to you. Okay, that was all module 1. Does anyone have any questions for me about module 1 or about any of the pieces that we talked about, particularly the 6 advantages, such as, trading upfront for variable, optimizing by not investing in data centers, stop guessing capacity, pay-as-you-go improvements, pay-as-you-go prices and economies of scale, increasing experimentation and innovation, and then going global. Any questions, sir? Okay. Excellent. So let's talk about compute. And whoops, that's not what I wanted. Let's get this one. Let's talk about compute in the cloud, and we're going to talk about this, and then we're going to take a short break. The goal of this module, by the way, actually, let me do this first.